Hello everyone, I am Tejashree and welcome to my channel. Today we are going to discuss about the topic multi-tier data warehouse architecture. Before getting into the topic, let us know what is data warehouse. Data warehouse. It is structured by data integration from multiple heterogeneous sources. It is defined by Bill in 1990. The data warehouse is an integrated, subject-oriented, time-variant and non-volatile collection of data. A data warehouse is structured by data integration. It is a system used for data analysis and reporting. A data warehouse is deliberate a core factor of business intelligence. Data warehouse is generally referred to the data repository that is maintained separately from the organization's operational data. BI technology provides a historical, current, and predictive view of business operations. Without data mining, many businesses may not be able to perform effective market analysis, the strength and weakness of their competitors, profitable decisions, etc. Multi-tier data warehouse architecture. It is the architecture defined by data warehouse. In data warehouse usually have a three-level tier architecture, which is also known as multi-level tier architecture. That includes three tiers, which is bottom tier, middle tier, and the top tier. Bottom tier, which has the data warehouse server, middle tier, which has the OLAP server, and top tier, which has the front-end tools. This is the diagram representation of the three-level tier architecture, which has the bottom tier, middle tier, and the top tier. Here, in the bottom tier, it gets the data from operational database and external sources. The data will first be extracted and transformed, load, and refresh. It goes through the certain operations and then get into the bottom tier, which is data warehouse server. In this, monitoring, administration, data warehouse, data marts are visible in the bottom tier. Next, the middle tier, which has the OLAP server, which takes the data from the bottom tier and it gives the output to the top tier, which has the front-end tools like query report, analysis, data mining, and all. This data can be divided into different categories of a certain operational business or certain organization, where the analysis is a certain type, data mining is a certain type, and query report is a certain type, where the data is differentiated in three categories in this particular diagram. Next, coming to each tier explanation, we have the bottom tier, which has the data warehouse server. A bottom tier that consists of the data warehouse server, which is almost always an RDBMS. It may include several specialized data marts and a metadata repository. The bottom tier usually consists of the data sources and data storage. It is a warehouse database server, for example RDBMS. In bottom tier, using the application program interface, which are also called as gateways, data is extracted from the operational and external sources as we discussed before. Application program interfaces like ODBC, which are Open Database Connection, OLEDB, which are Open Linkage and Embedding for Databases, JDBC, Java Database Connection is supported. Data from operational databases and external sources, such as user profile data provided by external consultancies, are extracted using application program interface, which are also called as gateways. The basic examples of gateway containing ODBC are, which is Open Database Connection, are OLEDB, JDBC, Microsoft, and all. So, bottom tier, it's like a extraction of data from the external sources or wherever the data is available. It generally extracts the data, cleans the data, and it gives the correct information or the correct data to the middle tier, which has the OLAP server. That is the work of the basic bottom tier. Next, coming to the middle tier, which has the OLAP server. The middle tier, which consists of an OLAP server for fast querying of the data warehouse. The OLAP server is implemented using either ROLAP, MOLAP or HOLAP. These are the three servers which are known as the relational OLAP, multidimensional OLAP and hybrid OLAP. These are the extended relational DBMS that maps functions on multidimensional data to standard relational operations. A multidimensional OLAP is a particular purpose server that directly implements multidimensional information and operations. And a hybrid OLAP, it is like a combination of relational and multidimensional online analytical process, which is the full form of OLAP. Next, it is the ideal option for a seamless functional flow across the database systems when the repository houses both the relational database managed system and multi-dimensional database managed system. So the middle tier, which takes the data from the bottom tier, it generally gives the data to the particular servers for a particular purpose, and then it takes the output from the particular servers, and then it gives the data to the output, which is nothing but the top tier. Next, let us discuss about this top tier. Top tier, which has the front end tools like querying, data mining, analytical report, which we saw earlier in the diagram. The top tier that contains the front-end tools for displaying results provided by OLAP, as well as the additional tools for data mining of the OLAP generated data. So the top tier is the front-end client layer, which includes query and reporting tools, analysis tools or data mining tools, etc. The few top tier tools that are often used as Crystal reports, Microsoft BI platforms, IBM Cognos and all. So the front-end tools are the end products of the particular architecture. This is about the architecture. And next, the advantages of multi-tier architecture of data warehouse are scalability. Various components can be added, deleted or updated in accordance with the data warehouse shifting needs and specifications. And next is better performance. The several layers enable parallel and efficient processing, which enhances performance and reaction times. Modularity, security, improved resource management, which is like different tiers can be tuned to use the proper hardware resources, cutting expenses and overall increasing effectiveness and all. Easier maintenance. This three-tier architecture is easy to maintain and it is simpler because individual components can be updated or maintained without affecting the data warehouse and the remaining parts of the data warehouse. And improved reliability. Using many tiers can offer redundancy and failover capabilities. So that's all about the three-tier architecture, and thank you.